So that brings us to collisions. Public virtual, but this one's got a line 16 as the extra added bonus. Now this one's flipped in style, so these guys are all hidden away at the top, and this one is all the public stuff. The only really unique one that's worth mentioning now is as the set collidable group, which is the templatized code you showed us before, that allows each object to essentially get its ID whenever you call this function. Okay. He's not particularly all too interesting. Oh, aside from the bsphere stuff, which I will cover more later. Submit collision. Yeah, these guys are all basically identical to what I had before. Create commands, delete commands, and then commands to enroll it in the collision manager, which I'll cover a little bit, and then bsphere for visualizer and other stuff. And for the bsphere collision, obviously. So we'll jump to the scene, we'll walk it down. Scene, collision manager, process collisions, and then all of the collisions are set through here, the collision registration commands. All very straightforward. Those are tossed into the scene register.execute commands, and they're actually processed using collision manager.process collisions. So for collision manager.process collisions, it will test them using test commands. And this is where things get all sorts of fun templatized craziness. Okay, so we have two different types of commands, collision test pair and collision test self, who both implement collision test command. Test self is the nice n squared over 2, where it compares all items in the set of items to compare, but the inner for loop only starts at the one after the outer for loop to prevent duplicate comparisons, and then it can use the visualizer, obviously. And the process callbacks is the one that will actually call the user code saying, call each of the two objects that collided, it'll call their collision. Collision test pair, and now has two sets of distinct groups of objects that could collide. So now it doesn't do anything tricky, it's just a true n squared algorithm. And then process callbacks if there is a collision, which I use as my math tools. I guess I should cover. For the intersection, we're currently only doing bsphere collision. So you get the distance between the two and the distance between the 2 points squared, and see if that is greater than or less to each other, and return flag. And then it uses the distance between 2 points squared. And then I have both of them here. I'm not using the second one. Don't worry. I just have it here just in case I ever need to only use this one. But I am using points squared. Okay. Okay, collision dispatch and collision dispatch base. This is where things get a little bit complicated, and it's probably easier to explain more from the user side. So when you go into user, so scenes. At the scene level, it sets the collision pairs and collision self if necessary. Which when you do that, this is like an open statement saying, hey, these are two types of objects that are going to have their collisions checked. And when you do that, that's when you get the collision pairs, collision selves, which will create those collision groups and the collision dispatches that I talked about. So the scene is where both of them, it allows you to create both of them, and you submit them all into Scene Manager to run. The scene has the collision manager who checks all of these, who then will use the dispatches to call back out the original guys, the original objects who have been reported as colliding. Collision pair, which you announce at the scene level. You're saying, hey, these object types are going to have to be compared. Player. And then for every object that has been stated as a collision, they need their corresponding part of the collision announced as a collision virtual void. So for the player object, they can collide with both the enemy bullet and enemy tank, which is explicitly stated here. Player collides with enemy tank and enemy bullet. Those have to be always together, because that's how we're doing the dispatchers with the templates. Things get mad and bad, or sad and bad, if it isn't otherwise. And then we can also go to the enemy tank and enemy bullet to see that they also... Enemy tank. What am I looking for? Okay, sorry, blank there. Collision player, and collision player bullet. And bullet. Again, player. So those will be the callbacks that are called if the collision manager ever finds a pair of objects that are close enough to collide. It will then call these corresponding functions on the objects who did collide. Oh, and they have to also announce the group that they're in. So set collidable group, and then set collidable model, which is used for updating the B-sphere, and then this update collision data, which again is updating for B-sphere and OBB and ABB later. And then we have, is the visualizer included in this? Sorry, one moment. It's not, okay. So, I will not cover that in this video, sorry. I think I covered the most everybody. It's got the usual attorney, yada yada, my delete ref, so you can do constant time deletion, but it also uses this map to find things. Oh, where am I? Oh, sorry, what am I saying? Collision data does not use that map. That is the alarms, or fuck, the inputtables uses a map. Collision does not. The only thing that's unique about him is this B-sphere, which whenever he does the update collision data, he will call compute data, which this math's probably wrong. I'll be honest, I don't fully understand what I'm doing wrong at this point. David tried to explain it to me, but he explained it to a different way.